Okay, the last construction that we need to explore, we're going to explore it as well with coordinate geometry in our heads. The last one is to find the orthocenter of a triangle. The orthocenter is the point of intersection of the altitudes of a triangle. And an altitude goes through a vertex and is perpendicular to the opposite side. So notice there in the last one we were looking for the centroid. The centroid is the center of gravity of a triangle, and it's the point of intersection of the medians, where a median goes through a vertex and the opposite midpoint. In this case, we're looking for altitudes that go through a vertex and are perpendicular to the opposite line. The orthocenter, this one is going to be far more difficult. It is different depending on whether you have an acute, a right-angled, or an obtuse triangle. Because in this case, the orthocenter does not have to be inside the triangle. So let's look at the first scenario where we're looking for the orthocenter in an acute triangle. Okay, the first scenario is where we have an acute triangle, or in other words, a triangle where none of the angles are bigger than 90 degrees. Supposing I had a triangle like this, A, B, C, and I was asked to identify the orthocenter of the triangle. I need to find two altitudes. The first altitude I'm going to try and find, it goes through the point B and is perpendicular to the line AC. So it has to be perpendicular to AC and it has to go through this point. In order to carry out this construction, we need to think of construction number 3. In construction number 3, we drew a line perpendicular to a given line going through a different point that wasn't on the line. So in this case, you just have to be very careful, and I would always tell students you can extend on your lines, okay? I'm trying to go through the point B and I want it to be perpendicular to this line. So you can just, obviously you need to use a ruler to be accurate, but basically you can just extend on that line. In order to do this construction, I'm first going to place my compass at B. And I'm going to draw an arc, and it doesn't matter, it makes no difference how big the arc is, as long as the arc intersects the opposite line twice. So I'm going to place my compass here and draw an arc that intersects the line AC twice. So I placed my compass here and I drew my arc. The thing I'm concerned with now are the two places where the arc intersects the line AC. So you'll notice why I told you could extend that line on, because one of my arcs is actually outside the triangle, which is fine, it makes no difference. But basically this point and this point are the important points now. I'm going to first place my compass at one of the points of intersection of the arc and the line AC. I'm going to measure roughly a distance of 2/3 between the 2 points. And then what I'm going to do is I'm going to draw an arc out here. So I placed my compass here and I drew myself an arc, for me about 2/3 of the way between the two arcs. We keep our compass at the exact same arc length, place our compass at this point and draw an intersecting arc. So you'll notice that when I placed my compass here and drew my arc, they didn't actually intersect. The reason for that is because the original arc that I drew, I didn't draw it long enough. But that's fine, it means that I'll just go back, I'll place my compass here and I'll just continue that arc on until the two arcs intersect. So now I'm left with a position where I have two different arcs, and the distance from this point to one of the arcs is the same as the distance from this point to the other arc. What I'm concerned with now is the point of intersection of the two arcs. If I join the point of intersection of the two arcs with the point B, then I'll be able to draw a line that goes through B and is perpendicular to the line AC. In other words, I'll be able to draw what I'm referring to as an altitude. So I joined up the point of intersection with the original point B, and that leaves me with what we're referring to as an altitude. And now what I'm going to do once again is I can eliminate my construction lines. Obviously in an exam you need to leave your construction lines where they are, but it's a lot easier for me to explain this if I eliminate them. So now that's one of my altitudes, but I need to find a second altitude in order to identify the orthocenter. The second altitude that I'm going to find is the altitude, or the line that goes through the point A and is perpendicular to BC. Now in order to get this altitude, once again I'm going to continue on this line, because I anticipate that when I place my compass here and I draw an arc that intersects this twice, I imagine one of them is going to be out here. So that's exactly what I'm going to do. You obviously need to use a ruler. You continue this line on. Then you place your compass at A and draw yourself an arc of any length as long as it intersects the opposite side twice. So I've drawn myself a blue arc here, and this is going to allow me to draw a line that goes through A and is perpendicular to BC. I'm concerned with the 2 points of intersection of the arc and the line. What I want to do is place my compass at this point of intersection, or either point of intersection, but I'm going to start off with this one, and measure an arc length roughly 2/3 of the way between the 2 points, and down here I'm going to draw myself an arc. So I placed my compass at this point and I drew my arc. Now what I'm going to do is keep my compass at that exact same distance, but place it at the other point and draw an intersecting arc. So I drew my second arc here. So the distance from the original point of intersection to the first arc is the same as the distance from this point of intersection to the second arc. Now what I'm concerned with is the point of intersection of the arcs. If I join this point of intersection to the original vertex A, that will give me my second altitude. So when I join that up, I join A to the point of intersection, that gives me my second altitude. Once I have 2 altitudes, I'm now going to eliminate my construction lines. Once again, in an exam, you obviously have to keep your construction lines. The key is here, the point of intersection of the altitudes is the orthocenter. So I now know that this point here is the orthocenter. There's obviously a third altitude in the triangle. If I drew a line through this point perpendicular to AB, it would also go through this point as well. So that's the last construction that we needed to explore in terms of coordinate geometry. So that's the orthocenter for an acute triangle. However, if we get an obtuse triangle, the orthocenter is not inside the triangle. So let's move on and look at more difficult shapes. Let's look at what would happen in a right angle triangle. So let's think about what happens to the orthocenter in a right angle triangle. The orthocenter is the point of intersection of the altitudes. And the altitude it goes through a point and is perpendicular to the opposite line. So I want you to look at the triangle ABC, where this angle here is 90 degrees. One of the altitudes of this triangle is the line AB. It goes through this vertex and it is perpendicular to AC. So that actual line AB is an altitude. Another altitude is the line AC. It goes through this point and is perpendicular to the opposite line AB. So in fact, in a right angle triangle, 2 of the sides in the triangle are actual altitudes of the triangle. If you try to get the third altitude, it would go through A and be perpendicular, and it would look like that. Ultimately, in a right angle triangle, all 3 altitudes go through the point at the 90-degree angle. So the orthocenter of a right angle triangle is there. It's at the 90-degree angle. So in this case, A would be the orthocenter of the triangle. So I'm not going to bother getting you to do that construction. That could become really important in coordinate geometry of the line. You need to understand that. But I don't think you'll actually be asked to construct that, because you don't have to do anything. Like, you already have 2 altitudes, you just identify it. However, let's look now at what happens if we have an obtuse triangle where one of the angles is greater than 90 degrees. Okay, but imagine if we were asked to identify the orthocenter in an obtuse triangle, or in other words, a triangle where one of the angles is more than 90 degrees. Like, for example, the one we have here. Once again, in order to identify the orthocenter, we simply need 2 of the altitudes. In this case, the easiest altitude to find is going to be the one that goes through B. The altitude that goes through B is also perpendicular to AC. So what I need to do is place my compass at the point B and draw an arc that intersects the line AC twice. Once I've drawn my arc, the 2 things I'm concerned with are the 2 points of intersection between the arc and the line AC. I'm going to place my compass at one of the points of intersection and measure an arc length roughly 2/3 of the distance between the 2 points. So let's say roughly this distance. Keep your compass on the point of intersection and you draw an arc out here. Once I've drawn that arc, I want to move my compass from this point to this point, but keeping the arc length exactly the same. So that I put my compass here and I drew an arc. I'm now going to place my compass here and draw an equal arc, the exact same length, and identify the point of intersection. So when I drew my arc, it looked like this. Now I'm concerned with the point of intersection of these 2 arcs. If I join this point of intersection to this vertex, I will have a line that's perpendicular to AC and goes through the point B. So when I join those 2 points up, I get the red line, which is an altitude of the triangle. And once I have an altitude, I now need to try and find another one. The next altitude that I'm going to find, it goes through the point A and is perpendicular to the line BC. But the problem is, if it goes through A and is perpendicular to BC, it has to be out here somewhere. It has to be outside the triangle. There's no way it could go through A and have a 90-degree angle with the actual line BC. So I need to use my ruler to extend on the line BC. Once I've extended the line BC, I'm going to be able to come up with another construction. I'm going to place my compass at A, and I'm going to draw an arc that goes through the line BC twice. So the arc that I've drawn actually goes through the point B and goes through a point out here. So now I'm concerned with these 2 points of intersection between the arc and the line BC. I'm going to place my compass at one of those points of intersection, and I'm going to measure an arc length of roughly 2/3. 2/3 of the way between the 2 points of intersection. Place my compass at one of them, and I'm going to draw myself an arc down here. So I've drawn my arc down here, and now what I want to do is place my compass at the other point of intersection, but keep it at the exact same arc length as this one. And I'm going to draw another arc that intersects this arc. So I drew my second arc in such a way that the point of intersection is equidistant from each of these points. From each of the original points, it's equidistant to the point of intersection. If I now join up A with this point of intersection of the 2 arcs, I will have my second altitude. So if I join up those 2 points, I get my second altitude. Now, what I can do here is I'm going to wipe out my construction line so it's clearer. The point of intersection of the 2 altitudes is the orthocenter. So in this case, my orthocenter is actually out here. If I had drawn another altitude, it would have been perpendicular to AB and it would have went through C. And it would have also intersected at this point. So I want you to just pay attention to that one, the difference between scenario 3 there and scenario 1.